Uh, okay, let's begin. Can you hear me, guys?
دكتور معك.
Okay. Good morning again. احنا اليوم طبعا رايحين to continue with chapter 1. Today we're going to talk about probability theory. طبعا I have some notes for you on e-learning along with the voice recording. I was hoping انه everybody had a chance to look at it. And طبعا مثل ما حكينا before, maybe we're not going to go through the notes in details. بس يعني نركز على الشغلات. إذا في حدا عنده سؤال يعني إشي مش واضح بنوضحه. وطبعا في شغلات مثل ما حكينا المادة طويلة هاي بالنسبة للprobability أو الراندوم يعني الراندوم variables بشكل عام مادة طويلة. فإحنا رايحين نركز على الشغلات اللي بنشوفها مهمة. فراح تكون أسئلتنا مقتصرة على إيش؟ على النوتس والشغلات اللي إحنا شايفينها مهمة إن شاء الله. I'm sharing with you page 10 of the notes on e-learning. طبعا هنا the first thing, and by the way بدي أرد أسألكم لأنه أول مرة بنستعمل MS Teams. لما طبعا شايفين أنتم النوتس اللي قدامكم ولا لا؟
دكتور كل شيء واضح.
بالنسبة للكورسر واضح الماوس؟
مبينة.
خلاص ممتاز. بس بدي أتأكد لأنه بعرفش بختلف كثير عن زوم ولا لا. معناته الظاهر نفس الشيء. أوكي. هلا مثل ما حكينا أول إشي بنحكي عن some terminology هون. يعني شو الإكسبيرمنت. طبعا تقريبا we talked about all of these four of them. الإكسبيرمنت اللي هي البروسيجر to perform والoutcome هي possible results of the experiment. والsample space طبعا حكينا عنها so many times, which is all possible outcomes. والevent عبارة عن set, يعني some set of outcomes. يعني احنا we've been using the term sets. It's the same thing as an event. Okay. And هنا we have an example to clarify يعني these terms. For example, if we have an experiment of rolling 2 dice twice, rolling 2 dice مش twice, just rolling 2 dice, فالoutcomes راح يكون 36 1 1 1 2 1 3 1 4 and all the way بعدين 2 1 2 3 4. فمعناته في عندنا 36 outcomes. كلنا بنعرف الحكي هذا. This is all possible outcomes. طبعا this is the S sample space. The events هون انت you can generate as many events as you want. طبعا you set the rules for these events. So the events, you can generate an event with a specific rule. For example, here event A is the sum of two numbers is equal 4. Two numbers, two outcomes. So 2 and 2 will be 4. 1 and 3 and 3 and 1. For example, this is just we have 3 outcomes with this specific rule. The second event, for example, the two numbers are identical. For example, like 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. There is nothing else. And then the third one, the first number is bigger than the second. The first number is bigger than the second. So 1 and 2, that's not possible. So the first column is not, there's nothing from it. So 2 and 1. So the first one is 2 and 1 is, this will apply. Then 3 and 1, 3 and 2, بعدين and so on and so forth. So this is basically, these are the what we mean by events. So events are generated by rules that you set depending on what you're looking for. Now we're going to talk about the axioms of problems. The axiom of probability, عفوا. Okay, probability has some rules. Okay, so we're going to focus يعني the probability based on 3 axioms. The first one, طبعا before we talk about this, let's define the probability. As you can see here, probability is a function of an event that produces a numerical quantity that measures the likelihood of that event. Numerical quality, okay, it's going to be like 0.1, 0.2 or something like that. طبعا notation مثل ما انتم شايفين notation هنا it's capital P. So if we have an event A, so the probability of event P happening, we write it as shown in this one right here, okay? And some books, they write it this way, the PR, probability of A. So both of them are okay. Yani if you write, if you see it this way or that way, both of them are correct, okay? So this is as shown in equation 1, okay? Now we're going to talk about the axioms or the rules of the probabilities. So the first one, and they are very straightforward, but يعني, they are, we have to adhere to these these axioms or rules. The first one, for any event A, the probability of A larger or equal to 0, as shown in this equation, which means if you see a negative probability, that's not possible. So the probability would have to be 0 or larger. And the next axiom, if S is the sample space for a given experiment, the probability of S is equal 1. So this is the maximum probability, of course, because S contains all of the possible events or possible elements. So if you take the probability of each element or each event and add them together, they cannot exceed 1. Okay, so from 1 and 2, from axioms 1 and 2, we can see that the probability is between 0 and 1, cannot be less than 0 and cannot be larger than 1. Okay, and here in the bottom we see S is known as the certain event, obviously, because it contains all of the elements, and phi or null set is obviously the impossible events because it has no elements. Okay. If we go to page 12 here, we talk about the third axiom. Okay, and the third axiom is talking about the intersection between two events or two sets. So if we have two sets A and B, and they are mutually exclusive, as you can see, the intersection between A and B is equal pi or 0, then the probability of the combination of A and B, okay, the union of A and B is simply the probability of A plus the probability of B. So that's very important. So what we're saying is, if we have two events, and these events are disjoint, as shown in this figure right here, they have no common elements between them. Okay, so the probability of the union of these two joints, A and B right here, basically you take the probability of A plus the probability of B. Okay, now this A and B right here, they generalize what we just talked about. So now we're talking, the first one, we're talking about two events or two sets. Now, if we have multiple sets, M sets, but where M is less than infinity in this case, the same thing. If we have M sets where all of the sets are mutually exclusive, as shown here, then the sum of all sets, the probability, the union of all sets will equal to the probability of each one of them, combine them together right here as equation 5. So if you want to see the union of all these sets, you take the probability of each one of them and add them together. And B is similar to 5, basically. The only difference is M in this case goes to infinity instead of, that's it. Okay. So this is really the end of the axioms, but from the above axioms, we can come up with some other rules or some other identities if you want. So, for example, equation 7, as you can see here, can say the probability of the union of A and B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. So if you compare 7 and 4, okay, the only difference here we have the probability of intersection. So what we're saying here in equation 7, if we have two sets and these sets are not mutually exclusive, and we want to see the probability of the union of these, we just add the probability of the first one, second one, and subtract the intersection between them. Of course, if they are mutually exclusive, this will become 0, and then we'll end up with equation 4 as shown here. Okay, that's all we're saying here. Equation 8, it says here the probability of what? The probability of the complement of A. The probability of the complement of A is equal 1 minus the probability of A. Of course, 1 is really the probability of S, the probability of S. So 8, we can say the probability of S minus the probability of A. Okay, that will give us the probability of the complement of A. Okay, and the same thing, equation 9, it says if the event A is less than B, okay, or belongs to B, let's say belongs to B, then the probability of A is less or equal to the probability of B, which is very obvious. Okay. Now let's go to equation to page 13, where we're talking about discrete uniform probability laws. Now on this page here, if we assume that we have M mutually exclusive, collectively exhaustive atomic outcomes, mutually exclusive, okay, and collectively exhaustive, okay. Atomic outcomes, it's a single outcomes, basically what we're saying, okay. This is what we mean by atomic outcomes. We're going to assume that each outcome of these M outcomes, they have all of them, they have equally likely occurrence. So it means the probability of each one of them is equal. That's what we're saying. But of course, they would have to be mutually exclusive and exhaustive. And we did talk about mutually exclusive before and last lecture, and we talked about exhaustive, which means that if you remember, exhaustive, mutually exclusive, we just talked about it. When you take the intersection of the elements or the sets, if you will, or the events, the outcome would be 0. Where this one, exhaustive, it means that each these elements or these M events will have to include all of the outcomes in the S, in the space, the universal set, if you will. Okay. If you forgot that, just go back to last lecture, and we explained that in details. So basically, what we're saying here, the probability of any outcome will be 1 over M. So depending on how many outcomes you have, and since they are equally likely, then the probability each one of them is 1 over M. For all M is 1 from 1 to capital M, as shown in equation 10. This is example 1 here. This is just a simple example. So we're saying if we consider tossing, flipping a coin, obviously the coin will either have head or tail. Okay, so we have 2 events, A1 and A2. A1 is H, A2 is H. Obviously, the probability and they are likely, equally likely to happen. Okay, so it will be 50-50. So that's basically what we're saying here. Okay, and similarly here, another example. There's no need to go through it, but it's talking about rolling the dice, and rolling the dice will have 6 possible outcomes. So each one of them will have 1 over 6. Okay. So if so, the probability of event, the probability of even numbers rolled. Even number, it means 2, 4, 6. So the probability of even numbers rolled. So you combine them together. So the probability of 2 plus the probability of 4, probability of 6. So you add them together will be equal to half. Okay, that's what example 2 is all about. Similarly, this. Yet another example. Okay, it's very similar. There's no need to go through it, but if you have any questions about it, we can do that. It's similar to the previous example, but it's talking about the same thing. A pair of dice were rolled. Okay, obviously the outcome is 36, and then the event sum of 2 dice is equal 5. Obviously, we have 1, 2, 3, 4. So each one of them, okay, 1 and 4 will be 136, 136, 136, 136. So we'll add them up. That's all we did here. Now, on page 14, we're talking about probability as relative frequency. Now, as far as the probability, we have two ways that we can find it. We can find it. Hello? في حد عنده سؤال ولا؟ Hello?
بس دكتور صاحبي مش موجود على التيم.
مش موجود ليش؟
ما بعرف، قال لي انه مش موجود على التيم معنا على المادة، وقال لي بعث لك ايميل امبارح.
لا ما شفت الايميل تبعه، ممكن انه بعت لي بس ما شفته. كان يو ميك ان انفايت فور هيم من عندك؟ ما بعرفش اذا بتقدر.
ما قدرت برضه اعمل له انفايت، ما بعرف ليش.
اذا يعني مش موجود هو من مره، يعني ما حاول انه يدخل ما قدر مثلا.
لا الفكرة انه انت ما دخلته معنا على الجروب على الام اس تيمز.
لا انا ما دخلت صراحه، هي الجامعه دخلتكم، انا ما دخلتش حدا صحيح. فاهم شو بقصد؟ هو سجل متاخر مثلا ولا ما بتعرف؟
لا بعرف انه مسجل معي يعني بدري بوقت عادي.
اوكي. خلينا بعد ما نكمل اعطيني بس بعد ما نكمل بديش بتخاف نخربط اشي هون، بعدين بدخل على النظام هون وبشوف من هو المسجل شو اسمه، اذا مش مسجل بنضيفه ما فيش مشكله. بس انا ما ضفت حدا يعني صراحه. زمان بالصيف والفصول الماضيه كان لازم نضيف كل واحد، يعني كل واحد باسمه. هلا المايكروسوفت تيم يعني بدخلوا على الماده وبشوف مين مسجل بها وبدخلوهم. هل هم مثلا they miss some people؟ ممكن. واذا ودالي ايميل صراحه ما شفتوش. لو شفته يعني امبارح تقريبا الساعه خلينا نقول 10 بالليل وانا على الكمبيوتر، فما شفت شيء. فممكن انه راح على خلينا نقول فايل ثاني، ما بعرف. بس على كل حال خلينا نشوف بعد المحاضره وبنحاول نضيف ان شاء الله. اوكي. alright. مثل ما حكينا ال probability we have two ways we can find it. We can find it through sets or events and axioms, or through relative frequency. Relative frequency basically it's depending on doing the experiments so many times. So for example, if you flip the coin say 10 times, okay, and you want to see the outcome, يعني the probability of getting head instead of tail. So what's the probability? If you do it once معناته بتكون half and half، صح ولا لا؟ If you do it twice, according to the relative the probability of as a relative frequency معناته بتكون 1 over مثلا 1 over 3 or something like that. So the more you do it, it's going to be more accurate. Okay, so if you do it 10 times and out of the 10 كان مثلا 3 heads معناته 3 over 10. This is the probability. If you do it 100 times and the number of heads out of the 100 كانوا مثلا 40 معناته it's going to be 4 over 10. And so if you do it 1,000 times, the same thing. So the more you do it, the more accurate. So this is خلينا نقول بيستعملوه بالساينس خاصة باللابات، بعض اللابات to get يعني more accurate. As it shows here, we have equation 14. That's basically the average of success. So this is the number, n is the number of times you do the trial. يعني مثلا flipping a coin or مثلا doing specific experiment, okay? And NA, which is يعني the number of times the tail. مثلا خلينا نقول if you're looking for how many times you receive a tail or head, for example, or a specific outcome. Okay, so you write the numbers, the top divide by the total trials. So the larger n, the more accurate the probability will be. And obviously, as it says here, if you need exact measure, so you do it خلينا نقول an infinite times. طبعا there's nothing infinite. It means you do it as large as possible. Okay, as many times as possible to get it. Okay, that's basically what relative frequency is all about. Okay. This is خلينا نقول lecture 4 let me flip to lecture 5 quickly عشان نكمل. Lecture 5, joint probability. Okay, page 15. Okay, the joint probability is the intersection. The probability of the intersection of A and B is called the joint probability. Okay, and it's given in this equation. Okay, that's very simple. Okay, so we know we talked about the joint probability, or the intersection between A and B, two events, and the probability. So this one here, it's basically it's called the joint probability. Okay, and it's given this equation. That's basically it. So the probability of intersection of A and B is equal the probability of the event A plus the probability of event B minus the probability of the union of A and B. Okay, and from there you can write equation 16 as you can see here. So the probability of this one, the probability of the union of A and B is equal probability of A plus the probability of B minus the probability of intersection of A and B, which we did see that last lecture, if you will, on page, I believe we did see that on page 15. Let me see. Page 12. This is the same exact equation, okay? Now, as you can see here, it says if A and B are mutually exclusive. If they are mutually exclusive, obviously the intersection between A and B will be 0. Obviously, the joint probability will be 0. Okay. So what that means, if you will, it means that you can't have two sets or two events are mutually exclusive and they have joint probability. They can't be joint, okay? Because if they are mutually exclusive, they are disjoint, okay? Obviously, the probability will be 0, okay? Conditional probability is very important to understand. Yet it's very simple, okay? ما بدها شيء يعني بس إنه لازم ننتبه لها لأنه رايحين نستعملها بعدة حالات إن شاء الله. So the conditional probability of event given that event B has occurred. يعني conditional probability, we have two events. One, خلينا نحكي the occurrence of one is depending on the occurrence of the other. So if we have two events, we have A and B. So we will say the probability of event A happening given that event B happened. Okay, يعني for A to happen or to occur, B would have to be it will have to be happening or occurred. Okay, that's basically what we're saying about the conditional. Something is condition يعني إشي بيعتمد على الثاني بما معناه. Okay, so as shown طبعا the notation here as you can see here, the probability of A \B. That's the notation we're going to use for conditional probability as shown in equation 19. So the probability of A given B, it will be the probability of the intersection of A and B divided by B. Okay, assuming that the probability of B is not 0, is larger than 0, because if it's 0, it will be infinite. Okay, obviously if A and B are not, if A and B, the intersection of A and B, if they are mutually exclusive, obviously this will be 0. The probability of this will be 0. Yes. Okay. So if A and B are mutually exclusive, then as shown in equation 2, the probability given A, the probability of A given B is equal 0. Now, if A is equal B, if we يعني the elements in A is equal to the elements of B, then the intersection of A and B is equal B, and in this case, the probability of A given B is equal 1. Okay. Going to equation 16, to page 16, if you want. If A is a subset of B, if A is a subset of B, okay, then the probability of given A, the probability of A given B, the probability of A given B is equal the probability of A divide by B. ليش؟ لأنه the intersection, since as shown in figure 2 here, since A is a subset of B, okay, so the intersection of A and B will be really A itself. So which means the probability of A divided by B. And if B is a subset of A, the opposite, it will be 1, okay? If B is a subset of A, it will be 1. Why? Because in this case, the intersection is equal B. So the probability of B divided by B is equal to 1. And we have two equations here, 24 and 25. The probability of, we did see that before, last lecture. And also the probability of the complement of A given B is equal 1 minus the probability of A given B. And total probability, we will see that next lecture, but I'm just gonna show you basically what we're saying here. If we assume, if we have a figure here, figure 4, take a look at figure 4. Figure 4, we have خلينا نقول different sets or different events, B1, B2, B3, B4, all the way to Bn. So maybe we have 10 or 15 of them, and they are all mutually exclusive, okay? And exhaustive events, mutually exclusive and exhaustive events. So mutually exclusive, it's right here. It means the intersection Bi and Bj, where I and j are different numbers, maybe B1 and B2, B1 and B3, and so on and so forth, is always 0. So B1, B2, B3, all the way to Bn, they are mutually exclusive. And also the combination B1, B2, all the way to Bn is equal to 1, is equal to S, okay? And from there, according to what we saw before, the probability of Bj is equal 1, okay? Because it's S, the probability of S is equal 1, okay? If this has happened, then, and let's say if we have an event A, so the probability of any event in S can be expressed in this. So because this one A, the probability of A is depending on, طبعا هنا أنا بس معين هون، بس هنا A is depending on B, B1, B2, B3، يعني كلهم، هاي لازم تكون لهون، okay؟ يعني خلينا نقول B, the probability of B depending on B1, the probability of B given B2, probability of, the probability of A given B1, the probability of A given B2, and so on and so forth, okay? So this is the combination of all these probabilities is called the total probability of A, because A is depending on each event, where these events are mutually exclusive and exhaustive, okay? So that's all we need to know. The total probability for A, where A is depending on these events, B1 through Bn, okay, is given in this equation. So you take the probability of A given Bj times the probability Bj, the probability of B of J, okay? We will see this again next لما نحكي عن موضوع ثاني راح نستعمل equation هذه. Finally, we have an equation here. We have an example here. This example is very straightforward. Let's go walk you through it quickly. If you have any question. What we do here, what we have here, we have a box where we have resistors, 100 resistors, and also if you take a look at the table, okay. So we have this table right here. Okay, أفضل هون. هلا في عندنا 100 resistors total. Now out of the 100 وعندنا 24 resistors. Their resistance is 22 ohms. Out of the 24, 10 of them they have 5% tolerance. كنا بنعرف شو tolerance، طبعا أخذتوه بالcircuits والlab. و 10% tolerance. 14 of them 10%. The same thing here. We have 44. 16 of them 10% tolerance, 24 5% tolerance, and they have this 47 ohm resistor. And the last part here, we have 32 with 100% ohms, the resistance, and they have 24 of them, they have 5% tolerance, and 8 of them, they have 10% tolerance. So as you can see, the total of this is 100 resistor, 10% tolerance is 38, 5% tolerance 62. So they all add up together. Now we are looking for 3 different events. So event A, it says draw a 47 ohm resistor. Now keep in mind that something else is given to us. And we assume that each resistor has the same likelihood of being chosen. So we have 100 resistor. So it means the probability of choosing resistor number 1, number 2, number 3 will be 1 over 100. And this is discrete probability, okay? And they're all mutually exclusive, if you will. هذا الحكي اللي حكيناه قبل شوية. Okay? So with that said, the first event A as a draw of 47 resistor. B, a draw a resistor with 5% tolerance. C, a draw a 100 resistor, a 100 ohm resistor. Okay, so if we take a look at event A, which is drawing 47, so the probability of drawing 47 ohms will be 44, لأن التوتال قديش شلون عندنا 44 resistors with 47 ohms. So and each one of them is 1 over 100, so it will be 44 over 100. Similarly for B, the probability of drawing resistors with 5% tolerance, في عندنا 62 of them, صح? So it will be 62. And the last one, C, event C, it says the draw of 100. هاي 132. يعني تقريبا الفكرة من the first one and the third one وين راحت؟ This one, the probability of A and C is the same thing. This one is 47 ohms and this one is 100 ohms. Okay. Now the joint probability. طبعا الجوينت probability كيف بنوجدها؟ إنه the intersection between the event A and event B, the first one. The joint probability of A and B will be the intersection of A and B. So for example, the first one here, خليني أعطيكم example, the first one. So the joint probability of 47 ohm and 5%. If we take a look at the table, في عنا هاي 47 ohms going this way and 5% tolerance. شو الجوint between them? We have 28% or 28 resistor, شايف? 28 resistor with they have 47 ohms and 5% tolerance, 28. Where the rest of them, they don't apply, and they have different tolerance. Okay, so that's how we ended up with 28. Now the joint between A and C, so A إنه 47 resistor, 47 ohm resistor, and C is 5% tolerance. طيب شو العلاقة بيناتهم؟ هاي 5% وهاي 47 يعني ما في علاقة بيناتهم. عفوا C is 100. C is 100. Okay, so ما في joint between them. Okay, and the third one, B and C. B and C the same as خلينا نقول the first one. B and C will be إيش 24 right here. لأنه B تحكي عن 5% tolerance و 100 ohms فبلتقوا هون عند 24. الconditional probability طبعا نستعمل results in these equations right here at the top. So the probability of A given B, the probability of 47 ohm given 5 tolerance. So we'll take the intersection or the joint probability, اللي هو equation 29, divide by the probability of B. Probability of B is given 62, so it'll be 28 over 62. The same thing here for the probability of A given C will be 0. The reason why, because this one is 0. And the last one is 24. واللي هي 24 right here divide by ايش 32. So this is a good example. Make sure to يعني على الأقلية if you miss something try to understand it. Okay. And that's all I have for today. في حد عنده أي questions بالنسبة للlectures for today؟
لا تمام دكتور بالنسبة.
اوكي يلا يعطيكم العافية. خليني اوكي في عندنا هنا عدد كويس من الزملاء، يعني مش كلكم، كنت I was hoping انه يكون اكثر. هلا الشاب اللي طبعا الموجودين خلينا اشوف اذا بقدر اعمل اشي هون، بتخاف. على كل حال if I lost you احنا نهينا. في حد عنده اسئله بشكل عام عن الماده، عن اشي ثاني؟ ما في اشي. اوكي بدي اشوف انه اذا بقدر اضيف حدا، او بدي اشوف مين الموجودين اذا في مجال يعني without losing you. خلينا نحكي ممكن اقدر، بدي احاول. خلينا نقول manage leave edit team. لا مش شرط. اوكي شو اسم زميلك اللي حكيت لي عنه قبل شوي؟ الو
الجولاني.
اسمه الاول اذا سمحت.
معتصم.
نعم
جولاني.
ما سمعتكيش كويس بالله.
معتصم فايز.
معتصم هذا هو معتصم ماجد رحال هون عندي، مش معتصم. اوكي هاي معتصم. هاي الاسماء كلها موجوده هون، فمش عارف ليش اسمه مش موجود. دقيقه شويه. على كل حال نقدر نضيفه احنا، بس يعني ممكن انها في يعني اشكال صار، بس خلينا نشوف تاكد انه اسمه مش موجود يعني. هلا هو مسجل بالشعبة هاي ولا الشعبة الثانية، شعبة الساعة 10؟ أكيد إنه مسجل بالشعبة هاي. ها؟
شعبة الساعة 8:30. هاي الشعبة.
أوكي دقيقة شوية خليني. طيب هلا خليك معي على الاي ليرنينج، خلينا نضيفه مع بعض. هلا زملاء الثانيين اذا ما في عندكم اسئله بتحبوا انه تو ليف ذاتس فاين، ما في عندنا مشكله. اوكي اذا بتحبوا تسمعوا ما في مشكله برضه.
يعطيك العافيه دكتور.
اهلا الله يعافيك. يلا سلام.